So this week I have the founders of Timescale, the creators of Timescale DB, Mike and Ajay. So welcome to the Data Exchange podcast. These are people I've known for many years. In fact, I think Timescale may have been first announced in in a conference I chair many years ago, one of the stratas. But
Timescale was the first public talk was in March 2017 in Strata, I think San Jose.
Oh,
And
right.
so it's definitely a conference that you chaired. So thank you
Right.
for giving us that initial visibility. It feels like a long time ago.
Long
It's
time
like
ago. My
five
God,
years ago.
5 years.
It's March. It's like 5 years, almost on the dot. There you go.
Yeah. But with COVID, add another 5 years to that.
It accelerates and expands. Yeah.
Yeah. Oh, so
Yeah.
before we get into the technology, just to get people excited about timescale databases. So, if you guys were to give a talk in a conference today, and I give you a few slides to highlight timescale data, time series databases with a few use cases, prototypical use cases for time series databases. So what would be on those slides?
I'll give you the business answer, and if you want more of a technical answer, you can defer to Mike. The business answer is number one, time series data used to be niche, right? Used to be niche within the world of finance, right? Econometrics, more recently observability, IT monitoring, really metrics. And when we kind of launched 5 years ago, every other time series database was essentially purpose built for one of those industries. You had folks like KDB in finance, and then you had folks focus on metrics like OpenTSDB, Graphite RD tool, Influx, a long list of folks there. And we came out believing that time series data was actually becoming ubiquitous and needed a true relational database, a general purpose database. So what we built was the first relational database for time series, something that's purpose built, but also completely versatile. And that's kind of proven out. And what we've seen the past 5 years is that time series data is become ubiquitous, and it's even far more reaching than we had even expected. And so in the beginning, well, maybe I'll talk about what the use cases we see now. I think typically we see kind of three pillars of use cases, but then there's also a long tail of other things, and nothing here is a majority. Everything is, just like a solid use case. So we have one pillar is IoT, and all that sensor data is time series data, and IoT itself is a broad spectrum of use cases between trucking, shipping, logistics, manufacturing, smart home, healthcare, athletics. This is a whole set of farming, right? That's one pillar. There's a second pillar around observability, which has continued to grow, and we do see a lot of use cases there, and not just metrics, but also logs, traces. Those are all things you collect over time. And the third kind of pillar is newer, and it's Web3 and crypto. And all that data is time series. And everything in the Web3 crypto world is time series data. In fact, the blockchain, you could argue, is an immutable, not performant, but immutable time series database. But people, they don't use it for the performance, but you could argue that's what it is. Those are the three pillars, but we also see other use cases that you wouldn't expect, like, we have a major record label using us for music analytics. And they're actually one of, I think, 3 or 4 customers who use us for music analytics. We see a lot of gaming, a lot of healthcare, a lot of folks kind of building kind of ML type machine learning type applications. Energy is a big area. And so time series has become ubiquitous. What we've built is the first true relational database for time series, which means that unlike relational databases where purpose built for time series, and we can talk about what that means, unlike time series databases, we're also a relational database. So you get the full ecosystem of Postgres. We're built on Postgres. You get the full ecosystem of Postgres. You get full SQL. We have a larger ecosystem than even Mongo because of this. And of course, you get the variety of data types, index types. You can store relational data, all this other data. And as a result, it's kind of fueled a lot of the growth of Timescale, where today we have, I think we've announced this publicly, we have over 500 customers. And in fact, we really unlocked our business over the last 2 years, and we've seen, 20x growth of revenue in just the past 2 years. And so I think to talk about
Yeah.
Use cases.
I
Yeah.
guess.
Yeah.
I guess. So, Mike, maybe you can answer this. So enterprise. So for enterprise use cases, at what point do I decide I need a specialized system? So in other words, obviously in the beginning, I have time series. I'm trying to get by with a modern data platform like one of these cloud warehouses or lake houses. So at what point is it justifiable to go to a separate system?
Yeah, so I think there's a, I mean, you mentioned, data platform or lakehouse. I think there's really two different kind of pillars of use cases or of technical use cases that historically in the database world, we talked about them as transactional data, OLTP, and analytical data, OLAP. And, the OLTP was the thing that was behind your e-commerce site, your banking database, whatever. The OLAP historically was reporting, was data warehousing, and that moved into big data, now moved into cloud data warehouses. One of the hidden messages, though, behind them is it's not just about, as an engineer, I would think of like the workload patterns, but actually a bigger point behind them is the who is using it and what are they trying to use it for. And so if you look at these, it often had a very different form of use. The traditional databases, OLTP, were used by developers. They were used to build applications. They were used to build kind of both internal and external applications, real-time dashboards, whatever. While the data warehouses that you mentioned, the cloud data platforms, those were often used by, in the old days, what they called business analysts. Then it became data analysts. Now they bring in some ML and become data scientists. But it's a very different use. It's a very different shape of that use case. It's kind of used internally to do long-term understanding. And so what we see is
the OLAP people now can support somewhat, let's not say completely real time, but near real time dashboards, right?
Yeah, but I think the flavor of how that gets deployed in the organization is still different.
Right,
when you talk about a real-time dashboard, you'll have a product team, or a sales team or somebody who says like, how do we build a dashboard on top of our data warehouse? And so the platform that you're building is, let's throw a bunch of data initially in a data warehouse, then in a Hadoop cluster, now in our cloud data warehouse. It's just all this random stuff, but then we let other people across your organization like build their own dashboards, whatever. While when you think about the analytical use case that we talk about, it's somewhere between these two things, right? It's between the traditional database that sits behind your public application and your internal only data warehouse that's used for that's not used by developers. Timescale DB is often used by developers to build analytical applications. And so it's actually rare that we find somebody's like, oh, I'm on a cloud warehouse. Now I'm going to bring in a time series database. It's like, I am building this application, whether or not it's internal dashboards, whether or not it's customer facing. Jay talked about athletics. I mean, connected fitness. When you're riding your bike, you have sensor data coming off of the device. You have your leaderboard. You have your tracing. This is all analytical data. It's all time series data. It's part of the core product experience. That's not throwing that in a data warehouse and like maybe some random person. That is part of your developer pipeline, and your developers are using that to build their applications. And so that's where we see people who look at all this use case, look at all this data that is a core part of their business, is not just something that they are throwing to sales team to like do, occasional quarterly reports. That is a core part of the business, and that's when they turn to something like Timescale DB.
So I guess, Ajay, I was looking for you to tell me about enterprise use cases, and then you started talking about crypto and Web3. Tell me about enterprise use cases.
Well, I think, I'll say a couple things. I think number one, what we're seeing here, it isn't just a crypto thing or an IoT thing or observability thing. We're just seeing, I think it's a relational database thing. And I think what's happening is that, developers are collecting time series data for a lot of reasons, but fundamentally because like storage keeps getting cheaper, compute gets more powerful. And as all companies become software companies, which is often called digital transformation or whatever trend you want to call it, they end up wanting to collect data the highest fidelity possible to make the best decisions they can. And time series is the highest fidelity of data you can capture. So in fact, all companies have time series data. So one thing I do want to stress is that I'm happy to talk about use cases, but it's really an industry-wide thing that's happening. And the trends we're seeing is, time series is ubiquitous, Postgres is resurging, and SQL has been reestablished as universal language for data analysis. From day one, our bet was the intersection of those three was needed, and it didn't exist. It still doesn't exist except for Timescale. And that's really the three tailwinds, time series, Postgres, and SQL, that have driven all our growth and what's led to our most recent round, where we just raised 110 million from Tiger at a over $1 billion valuation. So that is I think that's the high level story. The enterprise use cases is interesting because I think enterprises, they don't use the product differently than the non-enterprises do. I just think that their kind of procurement processes are different. Mm-hmm. But if you look at crypto, we see a broad spectrum of folks. Some people just pay us $29 a month. Some people will spend hundreds of $1,000s a year, right? IoT is something similar, So I observability is something similar, music analytics, something similar. So I think these are all enterprise use cases, but I think the beauty of our model is that, we're all, we could talk about this if you'd like, but we made this bold move a couple of years ago to make all of our software free. And so all of our enterprise features we made free 2 years ago. And so we only monetize via the cloud these days. And because we monetize via the cloud, we see this broad spectrum of use cases and broad spectrum of customer base. And, the larger companies, they just, often they need a little bit more attention, and they deserve that attention because their workloads get a little bit more complex, and we give them that attention. But I think the use case is not different.
So, yeah, it's interesting. So I guess Mike pointed out something that I guess I never thought about, but makes a lot of sense. Is it's really the personas, right? So and the users, but I guess my reference point, Mike, is when I look at graph databases, right? So which is completely different from what you guys are doing. There, I can get started without one. And in fact, when I start doing machine learning, I don't even need one because basically it's a different kind of computation model. But in the time series world, what you're saying is that most people actually are in the reverse mode. It's not like they're in a modern data platform. No, they're already trying to grapple with time series applications. And so it hasn't occurred to them to actually use their modern scale out data platform for doing the time series.
Yeah, so I mean, I think that there's two part of the question. One is, why do people start with what they do, and what do we offer them from day one? And so, our initial, when we launched 5 years ago, Timescale, it was about, we had users who wanted to, time series.
Great name, by the way. Great name.
Thank you. There's a lot of data. It's continuous. It grows. It's not, again, to your comment, it's not about static data sitting in some S3 buckets. It's sensor data, it's product data, it's sales data, it's blockchain data, it's IT data. It's all coming at you. And so, the first things that we looked about is how do we give people this seamless experience? They interact with all this data like it's just one giant table. They don't have to worry about management complexity. They don't have to worry about manual partitioning. We handle that for them, and we make it obviously faster, more cost-effective.
Mike, those people have some components that they are familiar with, like the messaging systems, Kafka, and things like this, right? So, but maybe not enough to go all the way to what you're describing.
Yeah, so I mean, I think how data originates is a slightly different question. We certainly see, message buses like Kafka. We see IoT has its own protocols like MQTT. We see product analytics come directly through ORMs. There's a bunch of different sources of data. In fact, it's observability through Prometheus and OpenTelemetry now. There's not kind of one standard across all these use cases. But I think the comment was at the beginning it was about scale, and we built compression and then multi-node and scale out and kind of petabyte. We have people storing trillions of rows, and we'll what looks like one
Yeah,
giant table.
I remember teasing you about multi-node for years. Yeah.
Yep. We were coming. It was coming. It's now, and now it's also managed on our cloud. So you click one button and you get a whole cluster set up, and you don't worry about it. But what we also came to realize, a couple of years ago, we kicked off this new effort that said, if you're a brand new user, you're starting a new project, how do we make sure that you see the value from day one? And we know that a lot of users actually, when they think about ease of use, it's not just about managing the data at scale, it's about what they actually do with it. And so we actually really set up a whole effort to say, how do we know that you're focusing on this like analytical use cases, the time series use cases. So how do we build within SQL? So we support all of SQL and PostgreSQL, and people love how to use that. It works with all their tools. But now how do we make it even easier? And how do we kind of supercharge it for time series? So we have something called hyper functions and this new kind of pipeline functions, where it's basically a lot of advanced features for doing sketching and sampling and approximation and fancy algorithms around there. And then even within SQL, we've embedded these things that you would kind of appreciate from kind of a domain-specific language, almost like Spark, where you have these little pipeline operators where you could, in a SQL statement, take kind of like a stream of data and then run it through a set of operators to sample it and downsample it and convert it, again, to really drive to users. You could use SQL, you could use your other tools, and now it's kind of supercharged for these time series use cases. And so you kind of asked, like, why would somebody start, why pick Timescale maybe compared to storing it in a traditional relational database? Well, it's easier when you start, and it scales better with you. It scales to larger size, it's more cost effective, more features, et cetera.
So Ajay, so how do you guys decide what's open source, what's not open source?
It's a great question.
Is everything open source, I guess?
So a part of our code base, so first we make all of our software free.
Yeah.
We don't have any enterprise features. We
free
hold
as
back.
in beer.
All of our,
and it's all on, free as in beer, and it's all on GitHub. Yeah.
And it's all on GitHub. It's all in one repo. Part of our code base is Apache 2, and we've never relicensed anything.
No, but Mike just rattled off a bunch of things there, and it's not clear how much of it is Postgres. So
So part of our code base is Apache 2. Part of our code base is under a new license called the Timescale license that we developed. Now, the Timescale license is open source in nature, and it gives you a lot of things that open source does. The one thing it prevents you from doing is from being able to offer those features as a SaaS service. And this is really an answer to the cloud providers strip mining open source, and it's in order for us to protect our business and protect our R&D investment, and that's worked out really well. Some of the features Mike's described are in open source. Some are in the Timescale license. It's pretty granular, to be honest. For example, hyperfunctions. I think time bucket, first, last are open source. Some of the sketching approximation functions are Timescale license. I think in general,
it sounds like so everything is open source because everything is in GitHub. But then the license changes.
I need to be very careful because I think open source means a specific thing to some people. And so everything is in GitHub. Everything
available.
It's all source available.
Which means you can look at everything.
You can look at it.
Audit everything.
Exactly. It's the same workflow. You can fix your own code. We include the right to repair and all those things, the right to improve. But the Timescale license stuff, because it prevents you from running it as a service, it's not an OSI sanctioned license. And so by the strict definition of open source, it's not open source. But to most of our audience, we have found most of our audience, they actually don't care if something is OSI license sanctioned. What they care about is the other things we describe. Is it free? Can I see the source code? Can I modify the source code? What is the workflow? Is filing GitHub issues? Okay, cool. And so from that degree, I would say it's, if there's a spectrum here between open source and proprietary, it's like over here where it's not quite OSI sanctioned, but it's probably as close as we can get while building a self-sustaining business. And what we found, to be honest, is that most developers in the world today, especially new developers who are not in the US, so say folks in Germany or India or Brazil, they care less about what the OSI is sanctioned, and they care more about, is it free? Can I look at the source code? Is it on a GitHub? And for those people, it's essentially the same thing.
And you could embed it in behind your own SaaS service. Like, what Ajay said, the only thing, you can't do is basically offer Timescale DB as a service.
I see. So you can basically even create some kind of product around it as long as it's not Timescale itself.
Absolutely. And lots of companies embed it, they ship it. You could find IBM products that embed it and ship it, so it is useful in a lot of, it's fairly narrow, the restrictions that
yeah. We have over 500 customers, but our community is like 50 times bigger. And our community includes people like IBM and Uber and the New York Stock Exchange and Cisco and Schneider Electric. List goes on, as well as a lot of smaller companies. And I think as a test, and when we launched this license, we launched it early 2019, so probably ahead of a lot of other people. And it was, some people thought it was controversial, but we knew that what developers cared about wasn't what people on Twitter cared about. It was a little different, right? And our community growth just continued to grow. It didn't really affect it, and it's kind of taken off the past.
So the Mike, as you say, the main personas are developers, right? So not data scientists, data engineers, ML engineers. They're developers.
Correct. Some people, once you have a Timescale to be running, that is useful. We integrate with R, we integrate with Python. Again, all that, great stuff being as part of the Postgres ecosystem, in that there's great connections to a lot of these, pandas data frames could speak directly to a Timescale database. But, most people are using it to embed in, developers to embed in their types of applications.
And historically, as Ajay points out, kind of these metric-based applications are like the DevOps people, or the ones who were first to gravitate towards this, right? So now with your solution, you don't actually need DevOps because it's in the cloud.
Yeah, it's not only, yeah. I think that is one, Jay said, observability is a big use case, but it's a lot broader. And I think, frankly, it was what Timescale enabled that allowed that breadth. For example, we use Timescale DB internally to help run part of Timescale Cloud. And, when we want to do analytics, it's the fact that we have event data and metric data in Timescale DB. And then we also have relational data in it as well, that, about users and kind of billing information or whatever. And it's actually having both that allows us to do things like actually build our own internal billing system is built on top of Timescale DB, because now we could join across usage with your customer and your billing plan or whatever. And that's enabled by the fact that it's not, doesn't just store time series data, but also stores relational data and allows you to build these great applications on top of that. And so I think why, DevOps was narrower is those initial use cases were Uber built a metric store, and it stored floats, it's timestamps and floats, and that's all, because they were building for a certain scale that only 0.1% of companies ever have to worry about, or 0.001% of companies ever have to worry about. And so for the other 99% of the companies, you don't need to build where your initial thing is, let's run this on 100,000 servers. It's, how do we build a much more powerful platform, that possibly doesn't give so much trade-off for going through, Uber or Google scale.
Let me ask you about, this is interesting. So you, Ajay brought up the ubiquity of time series. So historically, when we talk about time series, we talk about metrics or stock market prices, these kinds of things. But are we at the point where what we're talking about is really temporal data? So just anything with a timestamp. So in other words, at the other end of it could be unstructured, could be text, could be an image, anything with a timestamp. But you guys are a relational database. I'm not sure how you fit into the world where it's temporal data.
So I think two things. One is, I agree that we like to say all data is time series data. And that's because, most things, including what you mean, like images and text, often have a timestamp and you want to do analysis of it. Of course, we see lots of people storing text in Timescale and do it. If you're talking about like MRI data, maybe we should be storing MRI data in Timescale. There's like other, database or data stores designed for that, but there's a lot of it. But I want to go back to one earlier point that you made about, did it all come out of metrics? And, to what Ajay said, and you asked before about like enterprise use cases. And Ajay talked about like, I think we're in the last 5 or 10 years, again, I'm not, this term digital transformation gets turned out a lot. But what we saw is that in many different industries, they already had to deal with analytical or time series data, but were often locked into historical platforms. For example, in manufacturing or industrial, they had these things called industrial historians that are a form of time series database. They were just, in the old days, like shipped in this hardened appliance that you would like put in your factory floor. And all that stuff is moving to the cloud. And, now we have all these shipping logistics companies that would, again, store this stuff, used to do it on a ship, but now they want to put a cellular connection and put it all back into the cloud. So I think we, a lot of us who might have come from, engineering or cloud, think about naturally trends toward observability. And yeah, we know about the stock market, so we see that fintech. But I want to say it really was always in all these different places. But it's really been the last 5+ years that even cross industries and big enterprise that, we have some companies that have been around since the 1800s, right? Who are now putting more of their data in the cloud and want that type of modern cloud database to power their kind of next generation.
And this is where I think we are very different than every other company that is in the time series space. I think we have a much more expansive view of what it means to have time series data. I always found it odd when people would say, hey, time series is just metrics, right? And I would say, well, metrics is a type of time series, but there's so many other different kinds. And there's that old proverb of like the blind scientist and the elephant, if you know what I'm talking about, where someone, and it's, I think different people have seen different parts of the elephant. Some people say, hey, time series is just metrics, right? Other people say, hey, time series is just tick data, right? Other people would say time series, yeah, those are my logs, right? And I think we were probably the first company to see the full elephant and be like, yeah, but it's all time series data, the different types of it, but it's all time series data. And because it's all time series data, like you can't just build something that's kind of just for one use case. Like a metric store that only stores floats is not going to work for, the time series data you get in maybe the shipping and logistics world, right? Or a time series data that's hyper optimized for performance, right? Like you might have in finance, but has its own exotic query language. That's not going to work when, hey, maybe you need, maybe 10 milliseconds, 20 milliseconds is an acceptable latency, but what you really care about is like the SQL interface. So what really focus on is the developer productivity and versatility. So I think what's really set us apart is we kind of saw the full elephant. We have an expansive view of time series, and we focus not just on performance, but on like versatility, like reliability, and developer productivity.
So as you were talking there, it occurred to me. So when you have data, you have people who focus on different aspects of it, right? So there's people who live in the world of reporting, right? So analytics and dashboard. So applications, as Mike pointed out. But then there's the people who use it for machine learning. So where do you guys fit into the world of people who need to do forecasting, even multivariate forecasting? Let's set aside anomaly detection because that's kind of like people associate time series infrastructure with anomaly detection. But in reality, most companies actually need forecasting. Right. So.
Yeah, two things. One, you'd probably know this better than me, but I think I forget who recently was telling me that one of the biggest sources for like Spark jobs is data stored in relational databases. And so, I think the point is, yeah, it's powering all these applications, but now that the data's there and it's like relatively clean, anything that speaks to SQL database speaks to us. So again, pulling data into.
But do you guys have specific initiatives or integrations with the different ML libraries?
So two things. One is again, so Jaden, I don't think we could care of this. Timescale is while it has a lot of functionality, it's actually implemented as an extension on Postgres, not a fork. So we inherit this both. So what that means, but we've really been very careful about maintaining compatibility. I mean, you just speak a Postgres connection to it. So basically every tool that could speak to Postgres, that's basically JDBC, ODBC, you got a SQL interface, you have R, you got scikit, you got Tensor, like if they could pull it from a Postgres relational database, you could speak to us. So while we haven't built any of those integrations because we're already part of like the largest ecosystem out there. Now, to your comment, I mean, one of the nice things about our database is, again, it's a very mature operationally. You could not only set up like a single source, you could set up replicated for high availability. You could set up asynchronous replicas. And so one of the common applications of asynchronous replicas are in our cloud. With one click, you could fork a database, which is a little bit different. What people often do that for that operationally is that they give access to their data science teams to either an asynchronous replica or to a fork, so that that fork or asynchronous replica will actually get a very common or even kept up to date version of the live production data. But from a resource isolation perspective, it can't possibly interfere with their production database, which is serving live data. So there's not only these ecosystems, but kind of operationally, there's lots of ways that people integrate into workflows for things like reporting, forecasting, and whatnot.
So you folks are a company built on open source. So in many ways, the success of the company, if the open source project is successful, then that's great for the company. But not necessarily vice versa, right? So some companies, their open source projects may not be that successful. But how do you measure success in the open source project at this point? You know, in the early days of any open source project, success is measured by GitHub stars. But you guys are too far along to be playing that game, right? So
yeah,
GitHub stars is really fun. Yeah.
GitHub stars is a really funny game because I feel like it's one of the few public metrics people can track. So I feel like it ends up getting a lot of attention.
It's all VCs care about it. That's why people care about it, right?
Yeah, probably. And we found a few years ago, we actually found a disconnect between our GitHub stars and the usage that our telemetry was generating, and we realized that that they were not the same thing, you know. So we collect telemetry. Now it's opt out. You can turn it off. A lot of people turn it off. But we collect telemetry, you know, anonymized telemetry about, you know, we might get your IP address, but aside from that, it's like, you know, how much, you know, data you're storing, and that's kind of what we use to measure success.
Well, you alluded to earlier the size of the community. So how do you guys measure size of the community?
That's where that's coming from. So our telemetry will tell us how much data is being stored in Timescale DB,
I see.
and then we compare that to how much data is being stored by our customers on our cloud service, and it's 50x more in the community. But I feel like there are many community metrics. I feel like consumption is one of them. I think another one is, you know,
contributors.
Well, actually, I wasn't going to go down that route. You know, I was actually go down the route of like when someone asks about time series databases, you know, on Twitter, Hacker News, Reddit, you know.
Yeah. I've been meaning to ask you guys this. So how come everything you guys write ends up on Hacker News? What is do you guys have like a farm of people who upvote you, or what's the story there?
I wish it were that easy, because then we'd be spending.
And we are not a YC company, so we don't get the special Hacker News magic from that either.
That's a very good point.
Yeah.
So a couple of things. Community health we measure with like engagement, but also like, you know, just commentary you see on social, the many metrics.
Or
and
do
I
you
think
guys have like a Discord or Slack that you measure?
We have a Slack channel. I forget the last count. It might be close to 10,000 members, but we have a Slack channel. A community health is also like, hey, when someone posts a question, how quickly does someone not from the company respond with the answer? And lately it's been a lot, very quick, fast. You know, so I think those are all trending well. Hacker News is really interesting. You can't really game it, which I think part of Hacker News' success is they've done a really good job. That like
just time series databases are popular on Hacker News.
Here's what we found, and we don't game it. Here's what we found. What we found is that quality attracts quality. So we spend a lot of time on our blog posts. When we put out a benchmark, our benchmarks are often better than the other company's benchmarks, and they're very honest. When we came out with a benchmark versus Mongo, they're reproducible. We have the time series benchmarking suite, which is open source, and anyone can reproduce it. When we put out our benchmarks versus Mongo, we actually first identified the best way to store time series data in Mongo, which, by the way, was better performant than the method that Mongo recommended. And then we showed how
both Mongo's recommended way and our recommended way for Mongo.
So we improved Mongo, and then we benchmarked to show how we better than Mongo. With something like ClickHouse, for example, which came out more recently, we show the areas where ClickHouse beat Timescale. And a lot of them were not time series in nature, more analytical in nature, more OLAP in nature. But I think that to answer your question is, we spent a lot of time on, we don't really believe in like marketing, we believe in helping. And our blog posts are designed to be educational in nature, then to be fair in nature. And then when a discussion develops,
generally Hacker News seems to, that community loves time series databases. Not even your posts, the other time series posts also.
I would, I don't want to say any names, but I think there are other time series databases that don't get the love that we do.
Okay.
And I think one thing we found is like, we're just very open. When someone says like, I tried Timescale and it sucked, like, I don't know, some people might be like, oh, you used it the wrong way. Like, and we don't do that, we say, hey, sorry you had a bad experience. Like, what did you do? And then you engage them and people open up and they say, oh, I have a use
case. I have a use case that you guys cannot support, by the way.
We can talk about that 1 minute. Yeah. But I think to your point, we're just like genuinely try to be helpful. And we genuinely spend a lot of time putting out high quality content. It's all written by people in the company, and some of the blog posts I
see you and Mike in there getting in the mix.
Yeah. And so there's no trick to it. It's just you're just trying to do things the right way.
And two things I want to add, to Jay's comment, the reason we ask them, if somebody says I had a bad experience, it's not that we're trying to just like, it's not handling them. It's that in the end, like, why does an engineer who tried something not succeed? And how do we actually improve our product to enable them to succeed? So we actually want to hear that type of feedback.
Yeah, that's your audience, as you say, right?
It helps us build a better product. But to Jay's also comment, like, in the end, this is a technical audience. And I think in the end, like, Hacker News people want to learn something. They don't want to be preached to. And to the extent that our content is written for developers, often by developers, and it is educational in that way, I think is one of the big reasons why people seem to like to read it.
So how come Ajay shied away from the metric number of contributors? Is this a
I didn't shy away from it. It's interesting. I think that number, I don't know what the latest number is. I think there's some open source projects that are largely community driven. And there's some open source projects where most contributions come from the company. I think Mongo is an example where most contributions come from the company. There are probably projects at Databricks where most contributions come from the company, right? As opposed to Spark, which may be more community driven. Timescale is a project where most contributions come from the company. Now, there are a lot of reasons for that. Number one, the development is in C and in Postgres, and the amount of people who know that versus who know JavaScript
it's not in Rust.
Very different. Part of it is in Rust, actually. Part's in Rust, and but it's even part of the Postgres stuff is in Rust. But I don't know. I feel like people often gravitate towards these kind of traditional metrics of community contribution, and we more gravitate towards like kind of fundamental principles, which is like, what does community mean? A community means like there are people using your product. There are more people probably using your product than who pay you. There are people making money off of your product that you don't see. that they're people, kind of helping each other out, and kind of view themselves as part of this community. And I think that's what we've built. And I think the fact that we have 50x the number of people using us and not paying us money and the people who pay us money, I think it's a sign of a healthy community where the goal is to build a really big pie and grab a small slice of it. Now, does it matter how many contributors you have, how many GitHub stars you have? I mean, in general, you want people involved, and different ways to get people involved. And, contributing is one way, answering questions on Slack is another way, answering questions in the forum is another way, and so, I think there are many ways, and I think some are more quantifiable than others. So I think people gravitate towards them, but we more emphasize the ones that we think are meaningful.
Actually, as you were talking there, I had this idea for merging Web3 and open source. It's why not set up a DAO, a decentralized autonomous organization for your open source project, and watch how chaos can. Let's see if chaos can govern your project, right? So here's a.
I think someone should run that experiment.
People who've tokenized open source to you could try to the growth of it.
I think there's something. I think there's to be honest, I think there's something there. I think it is very tricky. It is very tricky to get right and to align incentives, especially when there's a strong financial incentive involved with tokens. I think there's something there. I'd love to see someone develop it.
In the crypto world, it seems like the flaw is the fundraise becomes the project. Once they raise the funds, we have the funds. Why do we need to build anything? Right. So anyway, so here's a use case, and I can let's see if I'll geek out quickly with Mike here. So here's a use case.
Why not with me?
Well, with you too. With you too. So Mike,
I have 2 degrees in computer science.
What about applications that are in the millisecond response in the following sense? I don't have time to store to a database. I have to analyze and learn. So so the reason I bring this up is that now you've got these frameworks around distributed actors, right? So the actor model, distributed actor. So now you can do real continuous intelligence at scale in situations like, I don't know, like self-driving cars or robots, where you don't have time to write to a database, pull it out, analyze.
So what Ajay said is, I think in the end, a lot of the technologies we build, Timescale DB, Spark, Databricks, they all have they're all part of a broader software ecosystem that developers put together to solve their problems. And, we kind of all have, I sometimes call that like spheres of like our ideal use cases. And then I sometimes even call them like people use off-label use, where they and I think sometimes people navigate to like, I know this technology, even though it's sometimes off-label, I'm going to use it. Yeah. But to the extent that there are absolutely queries that people run against Timescale where you get single millisecond performance. Like absolutely single millisecond performance is a common query pattern. But like if you're talking about, hey, I want to do a self-driving car, like do I do that with Timescale? Like, well, probably you should build that functionality in the car, because you don't want to trust your network connection and crash it. But I think that becomes part of like this broader ecosystem. Like if you're doing that, we see this use case actually. You make decisions, but you also want to store what has happened, because like you want to go back and actually like see, was I actually making those right decisions? So often you'll upstream from something like Timescale. You might be running an application, you're going off of a narrow window of data or initial buffer that gets written to Timescale or written to another thing behind it. You then build other applications that could, isn't only about what's happening in the last, 100 milliseconds, but might be based on what's happened in the last hour or day or whatever, and use those applications and dashboards. So I think it's part of the application. It's not going to solve every use case. We see plenty of stuff where like people use Timescale like on your manufacturing line. Sometimes they'll actually put Timescale. We've seen use cases where they run Timescale in the factory and then also backhaul that data to our cloud platform. And so one visibility is used for like applications when they have in the factory. They want, the foremans to actually see the data of what's happening. but then they want to centralize and collect it. And guess what? Like that connection from the factory to the cloud might be unreliable. We have places where they're actually in regions of the world, there's actually unreliable cellular connectivity. And so one of the reasons they have that, they have generators for the factories that keep that servers up, but they might not have a reliable connection back to cloud. So, I mean, I think that lots of developers have different deployments. I actually don't think this is as much a use case as much as, and this is what we talked before, like IoT and other things have just a breadth of deployment scenarios and not one size fits all. And so like anything else, it's always, important for the engineer, developer, technologists to like pick technologies and pick deployments that are really appropriate to their scenario.
And just to build on top of that, I think the database market is so big these days. Maybe 20, 30 years ago, it was one company, it was Oracle or someone like that, right? And I think today, every company's become a software company. Software companies are built on great databases. And by the way, you're probably going to use multiple databases for your application, right? Because it's just how infrastructure works. The relational database market itself is probably $100 billion market. So I think from our perspective, it's, Timescale is not the best use case for every data workload, and nor does it need to be. I think you should use the best in class thing. I think what will probably end up happening is that I think you'll have different categories, where you have certain leaders. I think Databricks is a leader in its category, Snowflake a leader in its category, and I think for us, it's time series is emerging as one of these major categories, and for Timescale, it's we're the best in class time series database. With this round, we've raised over $180 million, and which was more than anyone else in this space, which is a sign of maybe investor support of our momentum and our vision. And by the way, we have most of that cash in the bank, so we have plenty of fuel to grow this business. And so I think when we think about our opportunity, it's, then you'll hear a theme here. It's, we're not trying to be the best thing for everything. And I don't think anyone can be the best thing for everything. I think data workloads are very complex, but when it comes to time series, and it's particularly for developers, Timescale is best in class, and we're going to continue building on our product roadmap, serving our customers, serving our community, and growing to make this the next big database company.
And with that, thank you. I can talk to these guys forever. I have to say my instinct 5 years ago was correct. I have to say, in terms of seeing very early on that you guys were going to do cool things, and I guess I'm going to end this episode here. We're probably going to talk about their competitors after this episode. If you want to hear that, you'll have to subscribe to our DAO when it launches.
And Ben, I just want to say
you'll have the secret podcast along with the DAO.
There you go. And I want to thank you again for giving us that platform 5 years ago. It was almost literally to the day 5 years ago where we gave that first talk at Strata in San Jose. So thank you for that. And you were right.
And we'll have to talk before 2027. We'll have to talk soon.
That's right. Yeah. That's right.